Welcome back to the 5th episode of our inventory system for Unreal Engine. This is part number 2 for creating the slot widget and the item container widget. Let's get started. Now we create our items container in which all the slots are managed. We do this in the content drawer. We create a new user widget. Name it WB_slots container. Open the widget. First we search for scroll box. Select it and drag it onto WB_slots container. Select the scroll box and set the scroll bar thickness to 10. Under Style, Bar Styles, we change the color of the scroll bar. But first, we have to activate the checkbox at Always Show Scroll Bar so that we can see the scroll bar and that it is always displayed. Now we change the tint to this value here. Scroll down a bit so you can see it better. For hovered thumb image, we change the tint to the value here. For dragged thumb image, we do the same, but we just copy the values over. Right-click while holding Shift and left-click to paste. Now we search for Uniform Grid Panel. Drag the grid onto the scroll box. Select the Uniform Grid Panel. Rename it to Grid for Slots. Make it a variable. Scroll up again to see the padding. And set the slot padding values globally to 3. The horizontal alignment to center and vertical alignment can stay as they are. You can now see the grid in the top center as a very small green box. Compile and save it. Now let's move on to the graph. This is where all the fun begins. First of all, we need a few variables. One is total slots, which is an integer. This variable indicates how many slots we have in total and write to the grid. Then we need a variable for slots per row, which is also an integer. This determines how many slots are displayed per row, bin slots called. The next variable is inventory ref. This will be the reference to our BPC inventory component as an object reference. And last but not least, the variable for our slot widgets called slot widgets. This will be of type WB_item_slot. Be careful not to select the masters. That as object reference. We delete the two node events, preconstruct and event tick. We now create a new function called resize slots. This is where we will generate the slots. First we need a for loop. As last index, we drag our total slots variable onto the last index pin. Start the index here at 1. This is very important. Otherwise, we will create one slot too many again. Then we make a create widget. Here we will now create the widget for our slot. Make sure to use the widget named WB_item_slot and not the master slot widget. As owner, we take ourselves with getOwningPlayer. Now we have to go back to the slot. Here we create the variable inventory ref. As type, we choose BPC_inventory as object reference. This way we know to which inventory this slot widget belongs. We make this variable public. As we have already learned, we do this by clicking on the eye to activate Instance Editable. Don't forget to complete and save. Now let's go back to the slots container widget. The inventory ref variable we just created is not yet displayed here in the create widget. We right-click on the node and select refresh nodes. It's still not there. We forgot some important settings. Back to the slot widget, we forgot to set the checkbox to expose on spawn. Compile and save, and then we can now see the variable as a pin in the slot container widget. And the mang. By setting expose on spawn, we are telling the variable that when the widget or other blueprints are created, the variable is already available as a pin when they are created. If you still don't see the pin, right-click again, select Refresh Nodes, and the pin should appear. We now pass the inventory ref variable from our container widget to the slot widget. Next, we get slot widgets. Search for the add node for arrays. Connect the execution pins and write our just created slot widget into the array. Wait a minute. We forgot to change the variable slot widgets to array. We'll do that now. We have to confirm the change. After it has been changed, we have to reset the pins in most cases. Now we can connect the variable to the add node, and it works. Now we still have to set the index for our slot. Here you can, for example, set a reroute node by right-clicking on Add Reroute Node. Then we get variables with getSlotData from the slot widget. This is our variable that comes from the created widget WB_item_slotmaster. This one. Now we take the set members in S inventory slot. This allows us to set individual pins in the structure, which is stored as a type in the variable in a referenced way. Each time we write an element in an array with the add node, the associated index is returned, and we now write this into our slot data from the widget. But before that, we have to tell the set members node which pins we want to describe. The slot index will be important later when we create the drag and drop function. This way, we always know which index the slot has in the UI, so that we can assign the slot from our inventory to the correct widget. Next, we get the variable grid for slots. Search for add child to uniform grid. We bind the pins. Here we want to insert our created slot widget as content. If you want to know how exactly the uniform grid works, write it in the comments and I will create a detailed tutorial for you. To know at which position our slot is positioned in the grid, we can have that calculated. For that, we take the variable slots per row. Search here for division whole and reminder. The input pin for the dividend is our slot index. For our divisor, it is the slots per row variable. By the way, we forgot to set this before. We set it to 5 as the default value. We connect the calculated reminder value to in column. And we connect the return value to in row. To avoid some bugs that sometimes occur during drag and drop, we set the node set horizontal alignment to center and the node set vertical alignment also to center. Let's recapitulate the whole thing. We use the for loop to specify how many slots we want to create. We create the slot widget, write it to our slot widgets array, set the slot index for the slot widget so that we know which slot widget we assign our inventory item to, calculate the row and column position in the grid, set the alignments of the slot widget to center. Now compile and save, and the function is finished. Now we go back to the event graph. We take our created resize slots function and drag it onto the execution pin of the event constructor to initialize the slots once. Now we create a new event named setInventoryRef. This is because every time the items container is assigned a new inventory, the slot widgets in the grid should be updated based on the inventory. We grab our InventoryRef variable and drag it onto the execution pin of the event. This automatically sets a set for the variable. We drag the InventoryRef pin from the set node to the event, then the message add pin to node appears. This automatically creates an input pin in the event. The created input has the same type as our set node from the variable. Now we get the variable total slots as a set as well. We want to set the number of slots from our set InventoryRef in this. Next, we create another event called refreshSlots. Here we take the grid and do a clear children to delete any existing slots that may have been created before. Then we empty the slot widgets array with the clear node. Once we know how many slots the grid should have, and we have cleaned everything up, we call our resize slots function to rebuild the slot widgets using the new information. Now we get all the slots from our inventory ref and assign them to the created slot widgets from the resize slots function. To do this, we use a for each loop node on the get item slots from the inventory ref. We take the slot widgets variable and use getACopy to read out the slot widget. In the for each loop, we make a break on the read array element, which has the currently read slot. Expand the break so that we can see all the pins. Then we take the slot index, and with this slot index, we get the corresponding slot widget. In the widget, we now call the function update slot data. We have previously created this in our WB_item slot master. Connect the pins. Now we can call the event in the setInventoryRef event. Create a few comments. We comment on this with update inventory slot data into the slot widget. Here we make the comment, clear and refresh the grid container for slot widgets. We comment this as set inventory reference to our BPC_inventory component. We comment the event constructor event as, actually, we don't need this at all, we delete it. Compile and save the widget. This is what the event graph looks like now. Now let's go to the inventory widget. We're now looking for the WB_slots container widget and drag it to the bottom border. Select the border and set the padding values under content. Left to 20, top to 20, right to 10, bottom to 20. Right is set to 10 because of the scroll bar here. Compile and save it. Now go to the event graph, and here we have to pass the inventory ref to our slots container so that the container knows which slots it has to load. To do this, we get our character blueprint with the node getOwningPlayerPawn. Now we could go to the inventory component with the node getComponent by class. Search for the BPC_inventory here. But if we have more than one component, such as an additional hotbar inventory component, we will have a problem. That's why we are now creating a blueprint interface for our character. In the Interfaces folder, we create a new blueprint interface. Name it BPI_character. Open it. Here we create the function getCharacterRef. As the output value, we create the variable characterRef of the type BP_third-person character as an object reference. Remember, when you start with the first-person template, the blueprint is called BP_first-person character. Don't forget to compile and save. Now we go to our character blueprint on class settings. Here we add the BPI_character interface. Then this will now also appear directly under interfaces. We set the return value to getAReferenceToSelf. Save it. Go back to our inventory widget. Delete the node by class. Call our created interface getCharacterRef message. And now they know the object delivered from the player pawn and can directly search for getBPC_inventory and call our inventory component, or later also the hotbar component. Now we get our slots container here. Search for set inventory reference. You can also set the value of the variable directly here, but we don't want to do that. To avoid this error, let's go back to the container. Select the variable we created here and set it to private. Compile and save it. Now let's go back to the inventory widget. If we search for set inventory here, only our function appears and no longer the variable itself. If we set just the inventory ref variable, we have the problem that the grid is not generated because all the events are not executed. Compile and save it. Now we want to create a few more items. We go to the Items folder, right-click. Under Miscellaneous, select Data Asset and search for our PDA_item data. Name the asset DA_hammer. Open it. As item ID, we take hammer. For the icon, we search for tex_tools_10. As name, we take hammer. The description will be, a tool can be used to repair structures. Stack size is 1. The weight is 3.0. Save it and create another item. DA_meat. Item ID is meat. As an icon, we search for the texture tex_meat_03. The name of the item is roasted meat. Description is, a food can be consumed. Stack size will be 10. We set the weight to 0.8. Save the asset. Now for the last item. This time, we'll just do it with a right-click and duplicate. But there is an even faster way. We'll just delete that. Select the DA_meat and press Ctrl D. This will then automatically duplicate it. This will be our pumpkin item. Open it. Item ID is pumpkin. For texture, we take tex_seeds_07_B. Wrong has to be other texture. tex_seeds_07. Because we want our icon is transparent. Change the name to pumpkin. We leave the description as it is. We set the stack size to 4. Weight 2.5. Save and close the asset. Now we go to our character. Then we open the event graph. Here we want to add more items to the inventory. You could now copy the nodes and continue like this. But we'll do it with A for each loop. We'll break this link with Alt and left click. Search for each loop. Put the loop in between. Connect the item we want to add to the array element here. Here we now simply create a make array from the for each array pin, which will contain our items that we want to add. Now we can simply add the individual items that we want to add to our inventory here as pins. Here the editor already suggests a make s inventory slot of the structure, but we have already built a function for this. The function is called make item to add. We will call this now. First, we want to add the hammer twice. Oh yes, we forgot to add a few more pins here. We do that with add pin here. We connect item, make item to add pins. Then we add another item. As asset, we choose DA_meat, and we want to have 16 of them. Then another item, namely, the pumpkin. We want to have 25 of them. Now we have one pin left. We can simply delete it. Right-click on the pin and select Remove Array Element Pin. Now save the whole thing and try it out. Now open the inventory and we see that something is wrong. Okay, we forgot to connect a few pins and we are calling a function incorrectly. First, the function. In the WB_itemSlotMaster widget, we need to replace the function isSlotEmpty with isSlotNotEmpty. That was the first mistake. Before we go to the last mistake, open your WB_inventory widget. Select the size box and change the width from 650 to 450 and the height from 750 to 550. Now we go to the character blueprint. Select our BPC_inventory component and change the slot amount from 16 to 45, so that we have more slots. We output another print string with the note that we have added items to the inventory. Now we fix the last error in the WB_slot container widget. Here I forgot to pass the selected slot from inventory ref to our slot widget. Don't forget to compile and save. Now let's try it all again. Press play. Open the inventory. We now see the 45 empty slots. Close the inventory. Press the T key. You will see a message in the upper left corner that the items have been added. Open the inventory. We see the items. We close it again. Give us a few more items. Now our inventory is fuller. With that, we have completed part 2. In the next episode, we will then make the function that they are stacked together until the stack is full and then create it as a new item. Maybe we will also add the drag and drop function, because this is not difficult. Thanks for watching. If you have any questions or suggestions, please leave me a comment. If you liked the video, I would appreciate a like or a subscription. See you next time, guys.